Hello. So in this class, we'll do calculus AB or BC and the concepts of squeeze theorem. So we'll go through the concepts of squeeze theorem. We'll start with a basic problem and then we'll try to do the most challenging problem which can be asked in the AP exam. So let's start with the concept and need first. First thing in finding the limit is we do direct substitution like x is equal to a. But sometimes this doesn't work like that. We often get indeterminate form like 0 by 0, which is indeterminate. We know when it is something other than 0 divided by 0, we get undefined. Or 0 by k, where k is not 0, we get the answer 0. But when it is 0 by 0, it is indeterminate form. And then we do some techniques like rationalization and to uh, get the value of the limit. So squeeze theorem is one of the such techniques. So suppose there are three functions fx, hx, and g of x. So f of x is less than h of x and h of x is less than g of x. So we can draw a graph like this. Here we see that f of x is the smallest, then h of x and g of x. Or we can say that h of x is sandwiched between g of x and f of x. So, squeeze theorem says that the middle function, or we can say here the h of x, is trapped between two simpler functions, that is g of x and f of x. So, if both the simpler functions approach the same limit, that is L, at the same point, or a specific point C, then the middle function, which is h of x, is forced to approach the same limit. Okay, so this squeeze theorem says that if a function like h of x is trapped between two simpler functions, for here as shown g of x and f of x, and if both the functions they approach the same limit, which is L, given here at a specific point C, then the middle function, which is h of x, is forced to approach the same limit, which is L. So we can write it like this in the following manner. So squeeze theorem says that suppose that for all x on the range between A and B, and C is in between A and B, except possibly at C, we have the function f of x is less than h of x is less than g of x. So suppose the limit at C, where x approaches C of fx, and limit of g of x where x approaches C is L, then for the some value where C lies between A and B, then the limit of h of x when x tends to C is also L. So we have previously studied the limits also. So in this case, we only need to know that f of x is less than h of x is less than g of x for the values around C. Around x is equal to C because we are working with the limits. So we are only concerned about what is around C, not what is actually happening at C. So here C can be any finite number, plus infinity or negative infinity. and L can also be a finite number plus infinity or negative infinity. So squeeze principle is mainly used on limit problems when the usual algebraic methods like we used factoring, conjugation or algebraic manipulation, they are not effective. But we do require that we are able to squeeze the problem between simpler functions where limits are like easily comparable or computable. And okay, so let's do some problems, then it will be easy to understand. Hello. So this is the question given to us and we have to evaluate the value. So let's first try direct substituting it. So we see we can break this limit into two parts. We know the properties of limits. So limit x tends to 0, x square, that would be 0. But here, if we see that limit x tends to 0, means it is all uh, positive. And when we see when if x is which gives the value like where we end up having sine even multiples of pi, then it will have value 0. But if it has the odd multiples of pi, it will have 1. So basically, it will fluctuate between 0 and 1. So the limit will be not be constant, it will actually fluctuate. So this limit is not defined. Therefore, we cannot get the value by this method. So let's use the squeeze theorem. So we know that sine value, it fluctuates between -1 and 1. Sine function values are between 1 and -1 and 1. So we can write the three functions like this. Now we are interested to get something like this. So we will multiply all the sides by x square. So what we will get is -x square. So if we multiply by x square all sides, still this inequality holds true because we know x square is a positive value. So the signs will not change and this equality still holds. So if we graph here, we see that this is the graph of negative x square. This is the graph of positive x square. And the graph of sine square, uh, uh, x square sine pi by x will be something like this, which will be in between this because we know this is greater than negative x square and less than positive x square. So we see that as it approaches 0, the graph of x square sine pi by x, it is nearly at 0. Its value is, as it is approaching 0, the value of the function is also approaching 0. As x is approaching 0, value of the function is also approaching 0. So can we write this in the limit, taking limit of each sides now? So basically the graph of x square pi by x is getting squeezed between the graph of x square and negative x square. So it's basically we are using squeeze theorem or sandwich. So this graph is basically squeezed or sandwiched between both the graphs. And as it is approaching 0 from left and right side, it's approaching but as the x is approaching 0 from left and right side, the value of this function is also approaching 0. So let's find, that's what is the definition of limits. So let's find the limit now. So if we convert this statement into taking limits, of all the functions, then also it holds true. And if we find algebraic limits like this of this function is 0 and limit x tends to 0 of x square, like limit of x square where x tends to 0 is also 0. So we can rewrite this. So now as we substitute the values both sides, we see that limit of x square sine pi by x is greater than 0 and less than 0. It means it should be 0. Thus, the limit of this function is 0. So we found out the limit using the squeeze theorem or sandwich theorem. It is also known as pinching. So using this squeeze theorem, we found that limit of this function is 0. Now let's try to do more complex problems. Hello. So this is our next question and it seems to be a little challenging, but we'll break it into parts and find the limit and we'll use squeeze theorem for this. So we know that sine x values lies between -1 and 1 and cos x also lies between -1 and 1 because we need cos cube here. If we cube, then also this inequality stays and -1 is less than cos cube x, which is less than 1. Now if we add 1 and 2, so adding 1 and 2, we got the equation like this. Okay, 1 and 1, -1 and -1 is -2, and then sine x plus cos cube x, and this is less than 2. Okay, now if we have to divide by x minus 3, we know that as x tends to negative infinity, x minus 3 is negative. And if we divide anything by negative, like suppose this is negative x is greater than 3. If we divide it by negative, this becomes x is less than -3. So basically we change the sign when we divide it by negative. So x minus 3 is negative. So as we divide it by x minus 3, this equation, we change the sign from less than to greater than. Here from less than to greater than. And then now we put this as we are used to putting the less than sign. So we will change this equation in this form. Okay, this right hand side becomes here and the left hand side is here. Okay, now since we want to find the equation for this, we have got this part. Okay, and we want this this more to be added, like we want to divide it by 1 over x square. Now we multiply by x square because we need the x square in the numerator, and we divide by x square plus 1 here numerator on the denominator because we need that on the denominator, and because both are positive, x square and x square plus 1 both are positive, it will not change the signs. Now we'll try to take the limit for this function and this function, and we'll use the squeeze theorem. So let's find limits x tends to negative infinity for the left hand side function. So we know if we put this will give infinity, negative infinity or negative infinity, or it will be indeterminate. So let's divide numerator and denominator by x cube, the highest power of the denominator. As we divide by x cube, we see this is the simplified form. Now we'll just substitute x as infinity. So we know 2 over infinity or any number over infinity is 0. So it will be, so as we put 2 over infinity is 0 here, we'll get 1. We'll put x as a negative infinity and we will see that we get 0 over 1, which is 0. 0 over 0 is indeterminate. So we cannot directly put here, but we can do some manipulations and then we got the value as 0. So this comes out to be equal to 0. Okay, now let's find the limit for this. So as we did the similar way here, we multiplied and then the highest power of denominator is x cubed. So if we directly put here negative infinity, it will give us an infinity or an infinity, which will be indeterminate. So we divided numerator and denominator both by the highest power of the denominator, that is x cubed. So on simplification, we got this minus 2 over x and 1 minus 3 over x plus 1 over x squared minus 3x cubed. Now, as we put x minus any number over infinity is 0. So we got 0 over 1, which is 0. So we got the limit for this is 0. Limit for this will be 0. So we see that now we can substitute the values. So this limit we got as 0 and this limit we got is 0. So limit of the question give limit of the function given in the question is greater than 0 and is less than 0. It must be greater than equal to 0 or less than equal to 0. It means that limit must be equal to 0. So that is our answer. So from squeeze principle, we can make out that this limit of the function given here is equal to 0. So we can do one more problem. So we have to use this use squeeze principle to find the limit of x tends to 0 plus means all the positive values. And so let's start with the basic function. Let's study first the sine function. So we know for any value sine theta, its value varies from -1 to 1. So in place of sine theta, here it is pi by x. So let's replace theta by pi by x. So sine pi by x value varies between -1 and 1. It's greater than -1 and less than positive. Now, since we have to match this middle function with this function, we will take exponent of all these terms. So now as we take exponent of all these terms, this inequality sign still holds on because we are not multiplying by a negative number. All these values are positive because exponential function is always in positive and it is increasing. A typical graph of exponent is like this. So exponential function of a value, lower value is less, like e raised to power -1. It is lesser than the value of e raised to power 1. So it is continuously increasing. So exponential functions are always positive and they are increasing with the increasing value of x. So we can still maintain the signs. Like suppose this is x, this is greater than 3. If we multiply it by negative or 2, it changes the sign. But here, because we are multiplying it with the positive value, this inequality sign still remains. Now we have to multiply it by x square. So x square is also positive. So inequality sign still remains the same. After multiplying to x square with uh, all the left side, right side, and the center, we'll find the limit of left side, right side, and center. So now we will, after taking the limit of these sides, we'll try to find these values of left hand side, right side. We know that e raised to power -1 and e, they both are constant numbers. Therefore, limit of this function is 0. And limit of this function is, because e is a constant value, so when we substitute x, which is a positive value, this will also give us, value will be 0. So our limit of the center function is greater than equal to 0 or less than equal to 0. So left hand side limit is 0, right hand side limit is 0. And according to the squeeze theorem or sandwich or pinching theorem, we can say that a function that is trapped between two simpler functions, and if both the functions approach the same limit, which here is 0, then the function, the middle function is forced to approach the same limit and it has the same limit. So the limit here will be 0. So the limit of this function will be 0. So I hope the earlier questions were also you could have understood. If you have any difficulty, please let me know. We'll do more complex problem for the squeeze principle in the next class. Thank you. Thank you so much for joining, and we'll meet in the next class.